back to another session on Laplace transformation. So on our last video we did the Laplace of we actually learned how to derive the Laplace of the sine function of a constant. For example, this is what we did on our last video. In case you haven't watched it, we treated the Laplace of sine at, which is equal to a divided by s squared plus a squared. Now, if you haven't watched our last video, I advise you to go and watch it before we treat this new session on Laplace. So in this new session, we are going to be treating the Laplace of cosine of a function. In our last video, we treated Laplace of sine 80. So today's session, we are going to be treating the Laplace of cos 80. Now, similarly, on how we derived our Laplace of the sine function of 80, we are going to be deriving the Laplace of the cosine of 80. Now, this follows the same process we used in deriving the Laplace of the sine function of 80. So now we're going to proceed. Our first step now, like I said, the general expression for the Laplace of any function is what? The Laplace of a function of t is equal to the integral starting from 0 to infinity of ft exponential minus st dt, right? So this is the general expression for the Laplace of any function. So using this representation, we are going to be deriving the Laplace of cosine of 80 using the same representation. So now let's proceed. So the Laplace of cosine 80 will be equal to the Laplace of cos 80 is equal to the integral starting from 0 to infinity, right? Now this function of t will also be substituted for the cosine of 80, right? So this is cosine 80 exponential minus st dt. So now we proceed. The same process we are going to be applying our normal process of integration. But before we apply our limits from 0 to infinity, we need to integrate it. So after we integrate it, we apply our limit. So now let's integrate it. So integrating cos 80 exponential minus st dt, right? So in this case now we're having a function, we're having two functions of the independent variable. We're having a function of t here, which is cos 80. We're also having a function of t here, which is exponential minus st. So we are going to be applying integration by parts. So continuing from where we stopped, I said there are two functions of t, right? We have the cos of 80 and we have the exponential of minus st. So we are going to be applying what we call my integration by parts method. So what does integration by parts method say? The integration by parts method says the integral u dv is equal to uv minus the integral v du. So this is what the integration by parts method says. The integral u dv is equal to uv minus v minus integral v du. So here we need to collect my u and my dv. So I can say, following the sequential order for integration by parts method, which function will collect u or which function will collect dv. So the trigonometry comes before the exponential. So my trigonometry is going to be collecting my u and my exponential is going to be collecting my dv. So my u is giving us cos 80, and my dv is giving us exponential minus st, right? So I'm going to be differentiating my u and integrating my dv. So differentiating my u, this is du dt, right? Equals, now differentiating cos 80 is equals to minus a sine 80. Right, very soon I'm going to be going back to differentiation and integration as time goes. I'm going to be making more videos on differentiation and integration. So now integrating my dv, this is v now is equal to exponential minus st divided by minus s. We are integrating it with respect to t. Don't forget, t is my independent variable. So now this is what we have. So we are going to be substituting what we have here in my integration by parts method, my integration by parts formula, which says u dv is equals to uv minus integral v du. So u dv, which is cos 80 times exponential minus t, is equals to my u, which is what? Cos 80 times my v, which is exponential minus st divided by minus s, right? Minus integral my v, which is exponential minus st divided by minus s, right? Exponential minus st divided by minus s times my du, which is what? Now, if I make du subject to formula here, remember this is du dt, right? If I make du subject to formula here, what will I be having? My du will now be equal to minus a sine at times dt. So this is what I will be having here. Minus a sine at dt. So now, since minus will cancel minus, right? So we have minus will cancel this minus, right? So we'll be having cos at exponential minus st divided by minus s, right? Minus integral exponential minus st. Now we're having a here, and we're having s here, right? Both of them are both constants, right? So now let's take the a and the s at the back of the integral sign. So this one will be having a divided by s, right? Exponential minus st sine at dt. So now we have not really gotten our answer because we are integrating cos at exponential minus st. We have not really gotten our answer as far as there is still an integral sign left here. So for us, we need to still integrate this factor, right? So now we're going to integrate it. The same process we did, we are going to reintegrate it again. So taking only this side. So taking only this side and integrating it, we'll be having loss. So this is where we just stopped recently before I had to rub up the board, so we continue. So continue from where we stopped. I said we need to integrate this again, right? So we're going to be integrating this again. So integrating it again, we'll be having integral of sine at exponential minus s dt, right? Now I need to still reapply my integration by parts method. So now I said trigonometric comes before what? Exponential. So my u is going to be what? Sine at, and my dv is going to be what? Exponential minus st, right? So now we're going to be differentiating my u and integrating my dv. But first, I would like to remind you of my integration by parts method, which says integral v du is equals to uv minus u dv. Integral v du is equals to uv minus v du. Sorry, integral u dv. Made mistake. So integral u dv is equals to uv minus v du. This is where I like to write it. So this is my integration by part method. So what's my u? My u is sine at. My dv is what? Exponential minus st. So now for me to get my du and my v, I have to differentiate this to get my du and integrate this to get my v. So my u, which is sine at, right? Differentiating my u, I have what? U du dt, right, is equals to a cos at, right? Now goes my dv, which is equals to exponential minus st, right? Integrating my dv, I have v is equals to exponential minus st divided by minus s. So I'm going to substitute these values into my integration by parts formula. So integral u dv, which is integral sine at exponential minus st, is equals to u, which is sine 80, right? Sine 80 times my v, which is what? Exponential minus st divided by minus s, minus integral my v, which is exponential minus st divided by minus s, right? Minus st divided by minus s times my du, which is what? Now making du subject to formula here. Making du subject to formula, what am I going to be having? So I'm going to be having du is equal to a cos at times dt, right? So we're having a cos at times dt. So you see, if you haven't forgotten what we actually started integrating at first, we started integrating integral exponential minus st cos 80. That's what we started integrating at first. Now if you see, when we have recently integrated this one, we are still having exponential minus st cos 80 here. So you see, we are actually repeating what we started integrating at first. So now let's go on. You see, okay, so where we stopped last. So we've successfully integrated sine 80 exponential minus st dt, right? And now this is what we got. Now, but we are still having another integral sign here. Now I want you to look at, there is a pattern. So at first, we integrated exponential minus st cos 80, right? Now we integrated it at first and we got this, right? So now because of this integral sign, we have to integrate this again, right? Now and we got this. Now you see, we are still having exponential cos 80, repeating what we were integrating at first. So you see that there is a pattern. So before we go to that, before I teach you the next step to follow, so now let's really simplify this. So minus times minus is plus, right? So it becomes plus. So I can just clean up this place and put plus. So since we integrated sine 80 exponential minus st, and this is what we got: sine 80 exponential minus st divided by minus s plus integral exponential minus st divided by minus s a times a cos 80 dt, right? So we can take the constants a and s in back of the integral sign. So this is what we have: sine exponential minus s sine 80 times exponential minus s divided by minus s plus, taking the constants from this place, which is a and s, so it becomes a divided by s integral exponential minus st cos 80 dt. So you see, this is what we started integrating at first, in which we had this. So now we're going to be substituting this and replacing it with this, because this is what we integrated to have this, right? So substituting this back into this place, we have cos 80 exponential minus st divided by minus s minus a divided by s. Now removing integral sine 80 exponential minus st and replacing it with this, right? We're going to be removing this and replacing it with this. So putting this back in this, we'll be having minus as open bracket sine 80 exponential minus st divided by minus s, right? Plus a divided by s integral exponential minus st cos 80 dt. Remember, what we were integrating is the integral of exponential minus st cos 80, right, which is now equal to this, right? So this is cos 80 exponential minus st divided by minus s minus a divided by s integral sine 80 exponential minus st divided by minus s plus a divided by s integral exponential minus st cos 80 dt. So you see, we're integrating exponential minus st cos 80 equals, which is now equal to cos 80 exponential minus st divided by minus s minus a divided by s open bracket sine 80 exponential minus s divided by minus s plus a divided by s integral. The same thing we are having here is what the same thing we are having here. So you see, there's a pattern. So this actually repeated and we have this. So what we are going to be doing now. Okay, so guys, continue from where we stopped, right? Continue from where we stopped. Basically, this is where we stopped on our last process. So continue from where we stopped. So I said the integration of exponential minus st cos 80 is now equal to this, right? Now you see, we are still having the same value we are having here. We are still having it here, right? We are having a repeated pattern. We are having exponential minus cos 80 and we're also having exponential minus cos 80 here, right? So now we're going to be assuming let I be equal to integral of exponential minus st cos 80, right? So this is what I'm going to be assuming, right? So anyway, I say I replace it into the integral of exponential minus st cos 80. So this is integral of exponential minus st cos 80, right? So this is I is equal to cos 80 exponential minus st divided by minus s, right? Minus a divided by s open bracket sine 80 exponential minus st divided by minus s plus a divided by s Now you see we are having integral of exponential minus st cos 80 dt right here also, right? So you are going to replace it with this, right? So replacing it with I, we have what? I. This is exactly the same process we did on our last video when we were trying to get the Laplace of sine 80. So it's just actually the same process. So multiplying through by as, right? We are having I is equal to cos 80 exponential minus st divided by minus s minus multiplying through by as. So minus cancel minus, right? Minus and minus is plus. So this is plus a sine 80 exponential minus st divided by s times s, we have s squared, right? Plus minus as times as times a over s, right? We'll be having a squared divided by s squared I. So you see, to make I subject to formula, I need to take this over to this side and make I subject to formula. So taking this over to this side, we'll be having I minus a squared divided by s squared I. So first there's a mistake. So minus as times plus as is what? Minus, right? So minus times minus is plus. So this is minus. So when minus is coming back to the other side, it becomes what? Plus. So simplifying this now, before we simplify, so let's actually equate this to cos 80 exponential minus st divided by minus s, right? Plus a sine 80 exponential minus st divided by s squared, right? So this is what we are having. So we're going to be simplifying this. So for me to simplify this, I have to make I subject to formula, then simplify it, then take it to the other side and apply my limit. That's all. So simplifying this, taking I, making I, factoring out I, we have I open bracket 1 plus a squared divided by s squared, right? Then equal to this, right? Plus 80 exponential minus st divided by minus s plus a sine 80 exponential minus st divided by s squared. So simplifying this, we'll be having s squared plus a squared divided by s squared, right? It's I, all I, right? Now, which is now equal to this, right? So this is cos 80 exponential minus st divided by minus s plus a sine 80 exponential minus st divided by x squared. So making I subject to formula, that is taking this to this other side. So I becomes cos 80 exponential minus st divided by minus s plus a sine 80 exponential minus st divided by x squared, all bracket. So when this is coming over, there's an inverse, right? So this becomes x squared divided by x squared plus a squared. So now, since we have successfully gotten the value of my integral exponential minus st cos 80, right? Remember, I is equal to exponential of minus st cos 80 dt, right? Which is now equal to this, right? So this is cos 80 exponential minus st divided by minus s plus a sine 80 exponential minus st divided by x squared, open bracket, x squared divided by x squared plus a squared. So remember, we said I is equal to exponential minus cos a minus st cos 80 dt, right? So this is what we have successfully integrated the exponential of minus st cos 80 dt. This is what we have, right? So now our next step, remember our limit says from 0 to infinity. So we're going to put increasing our limit. So guys, so this is where we stop, right? So I said the next step we have to do now is to take our limits. Remember, the actual question said the Laplace of sine, the Laplace of cos 80, right, which is equal to this, right? No, the Laplace of cos 80, right, which is equal to the integral from 0 to infinity, right? It's not actually this. So since we have already gotten the integral of the exponential of minus st cos 80 dt, right? So what we have to do next is to apply our limit. So applying my limit, so we have the integral from 0 to infinity of the exponential minus st plus at t, right? It will now be equal to, taking the limit from 0 to infinity here, right? It will now be equal to, open bracket, cos at divided by minus s exponential minus st, right? Plus a sine at exponential minus st divided by s squared, starting from 0 to infinity, s squared divided by s squared plus a squared. So we are going to take our limit from 0 to infinity, right? So at first we need to take the limit for infinity and for 0. So taking the limit for infinity, so we having limit t when t gets to infinity, right? When t is getting to infinity of cos at exponential minus st divided by minus s plus a sine at exponential minus st divided by x squared to infinity, right? To infinity, right? Minus limiting t to 0, right? Limiting t to 0, we'll be having of cos at exponential minus st divided by minus s plus a sine at exponential minus st divided by x squared, close bracket. Then we have our constant, right? So when we're limiting this to infinity minus limiting this to 0, that's how we're going to do it. So we're taking our limit to infinity and to 0, right? So taking our limit to infinity, so the exponential of, remember when t is getting to infinity. So if I eventually put infinity into this place, so it becomes at the exponential of infinity. The exponential of infinity is 0, right? So 0 times every other one here is 0. The same thing goes for this. Putting my infinity here, everything becomes what? 0. So 0 plus 0 eventually is 0. So taking this t to infinity, everything here becomes 0. Minus, taking my limits when t tends to 0 is equal to 0. If I put my cos, let's actually work it out. So this is cos, taking t to be equal to 0. So this is cos 0 times exponential 0, right? Because there's t here, so this is exponential 0 divided by minus s plus a sine at, right? So this is 0, right? Exponential 0, right? Divided by x squared then times s squared divided by x squared plus a squared. So cos 0 is 1, right? Times exponential 0 is also what? 1, right? Divided by minus s plus a times sine 0 is 0, so everything here becomes 0. So this is 0 minus open bracket 1 divided by minus s plus 0 times x squared divided by x squared plus a squared. So minus times minus is plus, right? So this is 1 over s times x squared divided by x squared plus a squared. So s eventually cancels out s, right? So we are left with s over s squared plus a squared. So I can eventually say that my Laplace of cos at is equal to s divided by x squared plus a squared. So I want you guys to jot this one down. This is our fourth standard solution to the cosine of, to the Laplace of any cosine function. So this is the Laplace of cos of at is equal to s divided by x squared plus at. So now we're going to be taking a few, we're going to be taking 2 or more examples, then we move on to our next session. After a long process of mathematical calculation, so this is our conclusion that the Laplace of cos at is equal to s divided by s squared plus a squared of a plus a squared. So now let's take an example. Then it's very easy, so you get familiar with it. So example 1, find the Laplace of cos 3t Very simple. So since this is Laplace of find the same, we should find the Laplace of cos 3t. Now if I compare these two, I can see that my a is what equal to 3, right? So putting this here, this is equal to, remember s doesn't have any value, only substituting a for 3. So this is s divided by x squared plus 3 squared, which is equal to s divided by x squared plus 9. So this is very easy. So I have one example, I have one exercise for you to do. So this is your own exercise. So this is an exercise. Now you can comment the answer you get in the comment section below, so I know you are following me. So the exercise for you is find the Laplace of cos minus 2t. So thank you guys for watching. Please and please do so well to subscribe.